Box plots, lesson 13. So we're going to explore how box plots can help us explore distributions. Today's I can use the 5 number to draw a box plot. I know what information a box plot shows and how it is constructed. So make sure you have today's date, your icons, and you're ready to move on. Let's do a little warm up here. Okay, so here we have the birth weights in ounces of some puppies born and in a kennel. And they're obviously in order. What do you notice? Yeah, we have 13 is the smallest, 20 is the largest. Looks like 17 and 18 are probably our most. Actually, 18 is the most, so 18 would be our mode here. Or we can have more than one mode. It's just going to be the one that has the most. What about our mean? Well, you have to add all those up and then divide by the total number here. So with the 25 scores that or the 25 weights that you've got there added together and then divided by 25, you get 16 and 92 hundredths. And then the median. All right, I'm going to fast do it too. Oops, hang on. Okay, after all that, I know it looks like I just flashed things, but for me, I actually had to redo all of it. So the median here is 17. So you can actually see that all three are pretty close. In fact, I mean, the mean is just a tiny bit off of what the median is. So if we put this into a dot plot, it's exactly what we thought, right? We had our median, or our mode, here in 18, right? Because that's the one we've got the most on. We had our median here at 17 because that was the very center. And then our mean was actually really close. It was 16 and 92 hundredths. Does it make sense that the shape of this is going to be like this compared to our data? Well, I hope so, because, most of it was somewhere between 16 and 18. Really, 17 and 18 ounces was the biggest focus. So, which one of them was easier to see all of this? Like the center, the spread, the mean, the median, the mode. The median and the mode is a lot quicker to see here, right? I mean, you can make the argument that the median is quicker to see on the other, but definitely the mode is a lot faster to see on here. Was it as easy to find the mean, do you think, with this as compared to what the other? I think you can make the argument either way, that the table was easier to find the mean, especially since it was in order. If it wasn't in order, maybe it really wouldn't have mattered, because by the time you made the dot plot, you could have just found the mean. All right, so let's dig into our lesson and talk about box plots. Wait, no, not a dog in a box. Ugh. Anyway, let's do a little bit of a human box plot. Not actually, because this is obviously video, so we can't quite do that here, but I do have the data for us to use. Before we actually start talking about it, let's get some stuff written down here. So a lot of things to write down. Not huge as far as difficulty writing, but it is important that we understand these things. So a box plot, just to visualize, looks something like this. where you have some sort of box in the middle, and then you have lines coming off of it and some vertical lines on those ends. Another thing that this is called is, besides a box plot, it can be called a box and whisker plot. It just depends on what you're talking about. I'm just going to call it a box plot. So the minimum in this is right here, and that is the smallest value in the data set. So whatever the smallest value is, it goes there. The entire thing's broken up in quartiles. Okay, so to here, this is where quartile 1 ends, and that's the median of the first half of the data. I put this first, second quartile, because that's the median. We should know what just the regular median is. Okay, so the second quartile, which is right here on this one. Now, that doesn't mean it's always going to stay like this. They're all different shapes. This is just an example size. So the second quartile is the median of all the data. The first quartile is the median of all the data that came before the median. The third quartile, which is over here, is the median of the other half of the data. Which, if you think about it, most of the data, especially if it's something that has a spread that's not very wide, and it has a lot of data centered, kind of like what we did with the dog weights and ounces, it's going to make sense that the box is going to hold all of the majority of what goes on. And then we have, these whisker parts that come off showing the minimum and then the maximum, or what can be known as the fourth quartile. Most of the time, you're not going to see it as fourth quartile. You're going to see it as maximum. But the reason why these are called quartiles, because that quart does mean that it's 1/4 in some way. Not exactly a fourth as far as picture-wise, but it does represent 1/4, 1/4 of the data in some way. But anyway, the maximum is the largest value in the data set. Okay? So yes, I know there's a lot here, but you really do need to have it all. And you may want to draw out a picture to help you out, but we're going to do a couple quick little drawouts to do it too. All right, so I went ahead and got all the letters of all the students' names in a particular class. And these are all the letters, first and last, in this sample set. Okay, so how do we find median normally? Yeah, we got to put them in order, which we're still going to have to put them in order for doing this anyway. So let's go ahead and do that. I will do that hang on. Okay, so now I've got all of the data in order. So let's find some things here. So we found our median, and that's going to be our quartile, our second quartile, or I guess I should put it the other way, right? So second quartile, or the median, is going to be 12. And then how do we find the first quartile? Yeah, we're going to find the middle of this first half. Okay, so what you can't see is I'm using my thumb to cross and go over as I'm counting towards the middle. Okay, now I've got 2 in the middle. How do we find the median when we have 2 in the middle? Add and divide by 2, right? But they're the exact same, so the first quartile is 11. And then how do I find the third quartile? Yeah, it's the middle of the second half here, so. And we lucked out, actually, since these are, again, together. It's the same number, so yay, I don't have to think. All right. So now I need, underneath my not well-drawn line, because this doesn't draw the best line, I need these numbers again, but I don't need all the numbers. I just need a listing of the numbers. So let me add that. All right, so now we've got the InstaSolve done. Let's add in our box, okay? I'm going to use a drawing program to make it a little prettier. Okay, so remember that the first quartile has to be at 11. And I'm going to drag this over until I get to the third quartile, which is 4. Now, as far as your look, it doesn't matter how wide your box is. It can be wider if you need to, like up and down, but the length, I guess the height can be what you need it to be. Because sometimes, especially when you're looking at a lot of data, you'll see multiple, and so you have to compare those. So you don't want them too big. So the first quartile is at 11. The third is at 14. My second needs to be here at 12. My minimum is at 9, and I'm going to connect that back to the first quartile. And my maximum here is at 23. Now, I'm sure you've got straighter lines drawn on yours, but this is basically what it would look like. So while you don't have to copy down all the data, I would copy down this box plot and then label each of the parts. You know, that we had the first quartile, the second quartile, and that's the median. The third quartile, that's the median of the second half. The 9 is at your minimum. And 23 is your maximum, or this also can be the fourth quartile, right? All right, don't just write down the initials for these things. Make sure that you know what it is, and if you need to, make a little key. Q equals quartile. Thing you got to understand with taking notes, it's not always about writing everything exactly like the teacher. It's putting it in a way that you understand, but still getting the right information. Okay, let's get back to it. So where was the median in the box plot? Yeah, that was our second quartile, right? Okay. What about the IQR? IQR stands for interquartile range. So that's the range that's within the quartile. Well, that's between Q1, or the quartile 1 and quartile 3, right? Okay. And then at the end, we had the whiskers part, right? What are the whiskers? The whiskers just show the rest of the range from the minimum to the maximum. Between Q1 and Q3, how many people are in that? At least half of the data is in there, right? Somewhere around 50%, which makes sense since it's called quartile. Why might these be helpful? Well, it's just a quick way to look at and to understand the data in some sort of visual representation instead of just looking at the raw numbers. The raw numbers get a little crazy after a bit. All right, let's do a little bit about studying blinks. All right, so here we have several recorded blinks for 20 people. What's the median? Well, if you went through and counted, you would have seen that the median is going to be somewhere between 16 and 14 because this is an even number amount. You add those two together, you get 30. Divided by 2, you get 15. So 15 is our median. What's the median? What's the first quartile number? Yeah, it's going to end up being 11, right? Because that's in the direct middle of this data. And then here, yeah. So first quartile is going to be 11. Second quartile is, third quartile is 22. What's the minimum and maximum? Well, they did the data for us in order, so it's a lot easier, right? 3 is the minimum, 51 is the maximum. All right, so here's that data. And you can see that it was put as a dot plot and then with a box and whisker above. So the box and whisker can give you a little bit, or a box plot can give you a bit of a quicker look at the data. You know, with the data, we had that one extreme and we had another extreme as far as how many were in that particular piece. But you can see that the box does represent about half of the data, right? Because the rest of the data kind of spreads out here, spreads out here, but it's about half that's in there. So if you just look at the box plot, can you tell what any of the data values are? Well, you can tell what the median is, you can tell what the minimum and the maximum is, and you can tell that the majority of it falls in, you know, at least half of the information falls between these two parts, but that's it. You can't tell specific data values beyond those 3 points that are marked there. What about the data plot? Can you find the median in that? Yeah, you'd still have to count to find to it, and you'd find that, you know, the last from the small end to the last of the higher end is going to end up making it so that it's at that 15 point. Okay. And I think it's a little bit tougher to look just at this to try and figure out where the first quartile and the third quartile go, but, you know, it's still there. All right, so you should have some of this from before, but a box plot is a way to represent the data on a number line. Data is divided into 4 sections. The sides of the boxes are the first and third quartiles. The sides of the boxes, are the first and third quartiles, which we talked about that, how that's the median for that half of the data, and this is the median for this half of the data, and that the line inside the box is the median. The ones that are connecting outside are maximum and our minimum. So this data plot here shows a minimum of 2, maximum of 15. The median is at 6, or the second quartile. The first quartile is at 5, and the third quartile is at 10. So box plot, remember we talked about how we make it. We find the median, then we find the median of the first half of the data, median of the second half of the data, you know, putting it in order, and that helps us with drawing our boxes. The box itself tells you, the larger it is, tells you how much more of a spread there is in the middle, and the whisker parts, the lines that come off the side, can show you the range. Sometimes that shows a very large spread. Sometimes it shows a very short spread. And sometimes using a dot plot and a box plot together the dot plot can give you like more specific numbers, whereas the box plot can kind of give you more trends more easily to understand. And, you know, because it's so quick to look at, you know, if you've got 2 sets of data that you're comparing, makes it easy. All right, this is a super long one. Hey, thanks for hanging in.